These are the gate questions for the chapter on buckling. So, buckling, gate questions. Yeah, let's see. The first question is like this. The rod PQ of length L with flexural rigidity EI is hinged at both ends. Okay, so the rod is shown like this. We have one end here, one end here, and this is hinged and this is simply supported. So basically, or rather, roller supported. And this angle is 45 degrees. There is a force P being applied here. And this point is P, this point is Q. This is a force F, sorry. Now the question is, for what value of F this rod will buckle? It is provided that the flexural rigidity is L, the length of the rod, is EI, the flexural rigidity is EI, and the length is L. Now we have to find out what is the minimum force which is required to buckle the rod. So obviously we know that for a simply supported rod, for simply supported beam, the critical buckling load is given by pi square EI upon L square. This is what we know. So over here, if the force is applied like that in the direction of the beam, this is P critical, then it will buckle. So what value of force will cause P critical? What is the angle here? This is 45 degree. So we know that F cos 45 degree is equal to P critical, or that is nothing but pi square EI upon L square. So F is pi square EI upon L square divided by cos 45 degree. Cos 45 degree is 1 upon root 2. So this becomes square root 2 pi square EI upon L square. That is the answer. So let's see the solutions which have been provided, or the options rather, which have been provided. Option A is pi square EI upon L square. Option B is square root 2 pi square EI upon L square. Option C is pi square EI upon square root 2 L square. And option D is pi square EI upon 2L square. Now see, this problem could have been solved without even actually writing these equations and all. Let's see. The first option is obviously wrong, because it is given as pi square EI upon L square, which is the force or rather critical force required along the length of the beam. And because F is applied not along the length, so obviously it cannot be the answer. Similarly, because the force F is applied at an angle, so its component must be equal to P critical, and P critical we know is pi square EI upon L square, so F must be always greater than that. So obviously answer C is also wrong and answer D is also wrong. So that leaves us with only one option, which is option D, because in this case only the force F is more than this portion, and that should be the only answer. So without even solving, we know that this is the answer. Let's see what is question number 2. Question number 2 is a pin a pin-ended column of length L, modulus of elasticity E, and second moment of the cross-sectional area I is loaded centrally by a compressive load P. The critical buckling load P critical is given by. Obviously, it's a very simple problem. It just asks you to provide the buckling load for this case. I'm sorry, the diagram is not correct. The diagram should be like this. This is the L length and the Young's modulus E and moment of inertia I. For this case, we know that the answer is P critical is equal to pi square EI upon L square. So let's see what are the options which have been provided. Options are, first option is EI upon pi square L square. Option B is pi square EI upon 3L square. Option C is pi EI upon L square, and option D is pi square EI upon L square. So option D is the right option. Third question. The third question is the ratio of Euler's buckling loads for columns with the same parameters having, which means that there are two different columns which have been given. One has both ends fixed, so it is like this, and everything else is same, which means it has length L and EI. The other one is both ends hinged, which means nothing but a simply supported structure. So it is like this. So this is L and EI. So for this we know that P critical for the first case is pi square EI upon, for this case it is L upon 2 whole square, and for this case P critical 2 is nothing but pi square EI upon L square. We know that these are the answers, these are the options, or rather the values of critical loads. So now if you do the ratio P critical 1 upon P critical 2, we will get, I divide these two. So obviously this is nothing but, this gets cancelled out. So this becomes 1 upon L by 2 square divided by 1 upon L square, because pi square EI is common. So this is nothing but L square goes up upon L square by 4, which is nothing but 4. So that is the answer. So the options are A 2, B 4, C 6, and D 8. So the answer is 4, which is option B.